All right, just to catch everybody up to kind of where we are and what I was hoping we would accomplish this week is a focus on chapter 13 of your textbook, investigating the relationship between two variables. And I just want to put it out there one more time. Remember that I sent an email in case you have to remotely access the textbook. You should be able to download it online for free. So just make sure that you have access to the textbook, because it is going to be important moving forward as we go through these last couple of weeks. So all the material from this week came from the textbook. I posted 2 video lessons, which I hope that you saw. The first one was just kind of talking about the concept of different measures of association that we might look at, and I did an example of walking through a cross tabulation. So if you saw that video already, you saw that I walked through like the formula of testing a crosstab for statistical significance. I'm not going to expect you guys to ever do that yourselves, but I just wanted to give you an example of what that would look like. And then I'm going to post videos within the next couple days. I want to focus more on how we can do some of these things using the online statistical program. So I'll post videos of that coming up as well. So related to that, I also wanted you guys to try connecting to the virtual desktop. Did anyone try doing that? Anyone have success there?
Yes, I did it and it worked.
Oh, good. Okay, very good, Janae. Yes, I've been doing it myself. So this is a really exciting option because it allows us to kind of all use the same statistical program. We have access to it for free. And I already have a lot of experience with this program. So now I can be more adept at sending you guys like videos that will hopefully be helpful. So please.
How do we access it? Did you send us an email?
Yes, Zach, it's on, can you see my OnCourse page right now? This connecting to the virtual drive right here, this will give the instructions. So it's just basically, you really just have to click on a couple of different things and then type in your Wheaton ID and password, and you should be able to connect to this new screen that gives you access to actually a number of different things, but the reason we're using it is for the SPSS statistics option. So another video that I posted this week, which one was it? This one right here, moving your data into SPSS. I just briefly talked about how you could copy and paste your data from a Google sheet or an Excel sheet into SPSS. And so then later this week or over this weekend, I'm going to post some very short videos just showing how you can do descriptive statistics, things like standard deviation, frequency distributions in SPSS. I'll show you guys how you can do some graphs in SPSS. And then I'm going to start showing some more advanced statistics, these types of measures of association that we're talking about this week. So, oops, sorry, let's see. Sorry, someone's coming in. Hi, Sam, hopefully. All right, Sam is joining us. So that's what's going on there. Okay, any questions about that? Okay, so the second online lesson that I posted for this week was a short lesson about bivariate regression. So we've already been talking a little bit about regression as the course has gone on. So hopefully some of it felt a little bit familiar to you guys. And I talked specifically about hypothesis testing using regression, which is actually what you guys did in quiz 2. So kind of some of it's a little bit of a review, but then we're moving on a little bit as well. And that's why I chose the article that I wanted you guys to look at for this week, because I thought it had some really good visual representations of what bivariate regression looked like. So kind of my goal for today was I wanted to walk through that article together, and I wanted to see what questions you had and to see if we could interpret the regression results together. Because that's what I'm going to be asking you to do in quiz 3, your final quiz of the semester. It'll be same like all of our other quizzes about interpreting various aspects of the article, but the main focus will be on interpreting some of the regression statistics. So I want to walk through it today, and then I will post additional lessons so we can keep reviewing next week. But really, I kind of have two main goals for you guys right now is let's be confident that we can interpret regression results in an article. And then the second step is I want you guys to be able to do regression and understand the regression results in the statistical program. So the statistics will be the same, just the layout will be different. So I want to make sure that you guys are comfortable with both of those things. Okay. All right. Can you guys, do you see the article on your screen now? Okay, sorry. Okay, so if you've had a chance to read this article, I think that there's kind of a lot of interesting things going on here. We're taught the dependent variable in this article is electoral choice. So the likelihood that you would support a particular candidate in an election. And the key independent variable is actually candidate appearance. So it's something that we've kind of probably thought about in passing. This idea, does actually like looks matter, like looking presidential? When we say that, I mean, could that have an actual influence on individuals' propensity to vote for a candidate? One thing I really liked about this article, another reason I chose it, is because I thought it did a really good job talking about the potential for spurious relationships. So again, you guys have probably noticed that so many of the articles that we've been using for class, oh yes, okay, Zach's asking me to repeat the independent and dependent variables. So the dependent variable is electoral choice. So you're supporting one candidate over another candidate. The likelihood of supporting one particular candidate is our dependent variable, and the independent variable, the key one that they're looking at is appearance. Does appearance of the candidates matter? And so again, regression analysis as a statistical tool is very helpful, because what it allows us to do is look at the effect of one variable while holding others constant. So ideally, what that would mean is that you can, control for spurious factors. So if you could include the other independent variables in the analysis, control for them, we'll talk more about that, what that means, but still see that your independent variable has an effect, then you're showing not just a correlation, not just the two variables vary together, but you're able to show a causal relationship. And that's really our ultimate goal when we're doing hypothesis testing. But one thing I liked about this article was they were very intuitive in how they thought about the potential for appearance to be interconnected to other independent variables. Did anybody pick up on that, or kind of want to elaborate on what that means? Well, what I saw was, okay, so we're saying, does appearance matter? But, if appearance matters, then wouldn't appearance matter in your ability to raise money, your ability potentially to connect to voters? How do you isolate, if appearance does have an effect, how do you isolate it from other potential factors that would also increase one's likelihood to win electoral support? So they go through that in the article, and I thought that was very intuitive to think about, okay, how can you actually test the relationship between candidate appearance and electability? So that's one thing I liked. So look back at that in the article. And the reason I point that out is you're thinking about your own papers. It really led them to kind of justify their research design. And that in terms of, this is why we have to do an experiment to test this. We can't just test this with real world data because everything's so interconnected. But if we can do an experiment with a control group and a treatment group, a control group that gets no pictures of the voter, and a treatment group that gets pictures of the candidates, then you can really isolate that effect of appearance. So I would just recommend kind of thinking about that when you think about your own research. I thought they did a really compelling job talking about, okay, this is the potential problem. This is why I chose this particular research design. And then, this is how it affects the internal and external validity of my results. And they were very deliberate in this article talking about internal and external validity, which I thought was great. And again, that's something that I would love to see in your research papers as well. So also, just one quick note, one thing I noticed in quiz number 2 is some people were not specific enough when I asked how particular variables were measured. As we move forward, you're going to see it's really important to be as specific as possible. And when the researchers are not as specific as possible, that's going to cause problems for us when we try to interpret their results. So when I'm asking you on a quiz, like how is the variable measured, please provide as much details as you can. We can't just say through an experiment. The experiment is the research design. The measurement is talking about how, if I'm saying the measurement of the independent variable, that's explaining to me, okay, there was a control group that only received the names of the candidates. There was a treatment group that received the pictures. And then what we're going to look at is the difference in support between people who didn't receive the pictures and did receive the pictures. Like, that's how kind of specific I'm asking you to be. Because if you just say through a survey, that leaves so much unanswered to think about. Okay, what were the questions? What was the level of measurement? What's the scale look like? And as we move forward, hopefully you'll see why that's important. So again, also just something to think about with your research papers. The details are key. It might seem tedious, and you might think, oh, my reader doesn't want to know like every survey question I asked or the level of measurement of all my variables, but it actually is important. Okay, so you guys interrupt me with questions at any point. You can type questions to me. I can see most of you, so you can raise your hands. So please interrupt at any point with questions. Okay. Oh, yes. Yes, Janai?
Oh, I just wanted to ask, when we were discussing the level When we're supposed to give a lot of details, you were mentioning discuss the level of measurement and everything. Is that where we can kind of expand on that in the data code book as well to really give a lot of details?
Yeah, sure. So of course, yeah, in your assignment 2, you could have a code book. Um, in your final paper, you might just say, like how we sometimes see in the articles, you could say the details for my measurements are outlined in Appendix A, and maybe attach your code book as an appendix. That's an acceptable option too. For maybe your key independent and dependent variables, maybe you'll want to include a description right within the text of your paper, I would imagine. But if you have a lot of variables and you think it would just kind of be more intuitive to say, see Appendix A and just attach your code book, that would be an acceptable option as well. That's a great question. Thank you. Okay. So I'm just, I just want to pull up some pictures for you guys. So I'm going to kind of skip over the rest of the research design at this point, but you can interrupt with questions about it. But I thought, most people on quiz number 2, you guys have been good at kind of locating the information about the sample types, thinking through how that might affect the validity of the project. Everybody was able to figure out how many people were surveyed, what is the N of the design for assignment 2. So that looked really good. So I'll just kind of skip through that right now because I want to be able to focus on this type of data. Oh, did I already skip figure 1? Oh no, sorry, figure 1 was people. Okay, so this is why I chose this article in part, because I loved how they actually showed us what we call typically the scatter plot of the data. So when we're thinking about regression, there's different types of regression, but the model that we most commonly see is called ordinary least squares, or just OLS regression. And with an OLS regression model, again, remember that we talk about the direction and the form of the relationship we expect. So with an OLS regression model, we're expecting either a positive or negative linear relationship. So you're expecting the data to vary together in the shape of a line. And that's actually what we're looking at in this model right here. We're looking at the data plotted out. So each circle is going to represent one unit of analysis. So of course, in this example, our unit of analysis is people. So these are the responses generated based on the responses given by individual. Oh, I'm sorry. This is representing the candidates at this point in time. I apologize. But you could picture in your own data set that this could possibly represent countries. It might represent years. It might represent people. But what we're doing is we're actually plotting the data on an XY axis where the dependent variable is going to be our y-axis, and the independent variable is going to be the x-axis. So each dot just represents, where each unit of analysis falls on those two data points. And then what a regression model does is it draws the line, which we say kind of best fits the data. So we could picture if there's no relationship between two variables, the data is not going to look much like a line, right? It's just going to be kind of scattered all over the place. That would be suggesting no relationship. But if we're seeing some sort of tight kind of line pattern, then that's kind of suggesting a linear relationship between those two variables. So I'll show you guys in a video later this week, but you can very easily do a scatter plot in SPSS with any two of your variables to just begin to kind of look at it and think whether you're seeing a linear relationship or not. Obviously, we can use it to see outliners as well. We can see definitely some outliners in this particular data as well. So anyway, the regression equation is the equation of a line, and the beta that we've been talking about is actually the slope of the line. So as the slope of the line, the beta coefficients that are reported in our regression tables are telling us two different things. First, we look to the sign of the beta, and that's showing us the direction of the relationship. Is it a positive relationship? Do we have a line like the line we're seeing here? Or if it was obviously a negative relationship, we would see a line going this way instead. So the sign of the beta is important. And obviously the sign that you're looking for is dependent upon your hypothesis. So you should be able to look to the betas, the sign of the beta, and first say, okay, does the direction support what I would expect from a particular hypothesis? So that's the first thing. But also, as the slope, the beta speaks to the size of the relationship. So how we explain it is, what is the change in the dependent variable given a 1 unit change in the independent variable? So again, that's why it's so important to know how our variables are measured, because when we say a 1 unit change, that's completely dependent on the variable itself. So what's the change in the dependent variable given a 1 unit change in the independent variable? So for instance, if my independent variable was a 1 to 4 scale, a jump from a 1 to 2 on an ordinal scale could be a pretty big deal. However, if my independent variable was GDP in dollars, the change of $1 would not be a very big change. So we could have a very big beta, but like substantively, it might not be that important. So this will make more sense. This is kind of just an introduction to this topic, but I just want to point it out now, because when you think about what the beta is really telling you, you can see that it's completely dependent on how your variables are measured. Okay. So let's just move on and look at the next graph, and then I want to pull up a table for you guys. Okay, let me see. I can't reverse that one. Let me see if I can find a different one just to kind of go over this together. All right. So let's just take a look at table 2 for a second. So what we can see is always our independent variables are always going down our very first column. In a simple regression model, you would really just potentially have only to two columns, the column listing the independent variables and then the column showing the betas and the standard errors. However, in your quiz last week, you also saw an example of a table with multiple columns. The reason that there were multiple columns in the article from last week was because there were different dependent variables. So you might remember last week's article was a little different because there was one key independent variable across the models with kind of different measures of the dependent variable. So that's what I think some people struggled with in the quiz, was just kind of locating the correct data in terms of where on the table what did it correspond to the independent variable and the dependent variable from hypothesis 1. In this model, we also have some different things going on. We have it broken down by different types of elections, like you can see Senate and governor races and then like looking at it in different ways. So that's kind of all explained in the article. But the one I want to draw your attention to the most is kind of the one that's looking at number 1, comparing kind of all the different candidates, to the one number 3, all with controls. So what's different between those two models is, okay, what does it look like if we just look at appearance advantage versus what does it look like when we include our other variables of interest? So kind of just the first thing to look at, if I was asking you whether there was a statistically significant relationship between appearance and sorry, about the appearance and the photo in this example, we again have to look for the beta and the standard error. So the appropriate test statistic in the regression model is the z-score. So again, this isn't always specified in the articles, but we know because we're political scientists that when an n is greater than 30, we assume that our data is normally distributed. So that question on your quiz was, the sample distribution is the normal distribution. So the appropriate test statistic for our regression model is the z-score. And the formula for the z-score is the beta divided by the standard error. So the beta is always going to be in these charts. The beta is going to be the first numbers that we see. The standard error is reported under it. And the z-score would be the beta divided by the standard error. And what we're looking for is if you do that math, you're getting a number that's greater than 1.96. That's kind of the critical value that we'd be looking for within that normal distribution. But we actually don't have to do the math ourselves because they do it for us. And that's what those little dots are signifying. So if I go down to the bottom of my table, I can see that 3 dots indicate a p-value of 0.01. That's indicating that our data is statistically significant at the 0.01 level, which means that we're 99% confident that the relationship that's occurring between the two variables is not occurring according to chance. So it's a fancy way of saying, we think this relationship holds. We can reject our null hypothesis. The true value of the beta is not 0. What's the significance of the value 1.96 for the z-score? Okay, so I think someone's asking, why 1.96? That it's all based off, if you look at Appendix A in your textbooks, it's all based off the normal distribution and kind of what would be the expected values kind of based off certain sample sizes. So honestly, to tell you the truth, like how they got all those values is a little bit above my pay grade. I'm not a statistician, but basically it has to do with probability and likelihood of getting a certain value if it wasn't kind of the probabilities of getting that value if it was not true in the real world. Does that make sense? Okay, so just a couple more things. So we can see across all the different, we call them all the different models they ran, we can see that appearance advantage is statistically significant. One thing that you'll notice is that the size of the betas changes across the models. So the strength, the size of the relationship isn't always the same across the models. And we can talk about why that is. And we can see, for this one, for this particular model, it was not statistically significant. For the, 1, 2, 3, 4, 5. For the sixth model, it actually did not show statistical significance. One thing also to note is, of course, remember to always look at the direction of the betas. They're all positive. So as expected by the hypothesis, it's increasing the support of the candidates, so that that supports their hypotheses. So we look to whether the betas are statistically significant first, and then we can look to the direction to make sure the direction is what we're expecting, and also the size. One thing to note is if it's not statistically significant, it really doesn't really matter. It doesn't really help to speak about the direction, or it's not really appropriate, because what we're saying when it's not statistically significant is we're saying that 0 falls within the confidence interval. So that's 0 of no relationship. So we're showing, we can't be confident saying that it's a positive or negative relationship. Okay, so the final thing I wanted to show you guys is the R-squared statistic. I'm going to be going over this more next week as well, but I want you to have an introduction to this statistic as well. So every time you do a regression model, it's going to show you the R-squared. The R-squared is considered what we would call kind of a goodness of fit variable. And what it's really showing you is kind of when that regression line is plotted, when we plot that line that's kind of the best fit to our data, how much are the spaces between each observation and that line. So again, if you have a line you're trying to minimize those distances, if there's a strong relationship, you're going to have very, very little differences between the line and the data points. However, if that relationship is less strong, you can see some big outliners, you can see some big differences, and that's kind of really what that R-squared is looking at, is looking at the goodness of fit for the regression model. Another thing you can say about the R-squared is basically what it's showing you is what percentage of the variation in your dependent variable is accounted for by all your independent variables. So it's really showing how much are you explaining. So really, the higher your R-squared, really the better your model is, basically. So one thing you can see just in general is these R² are not huge, right? So looking at this first column, 15%. I could look at that and say 15% of the variation in the dependent variable is being explained by the appearance advantage. So, I mean, that's interesting to think about, but it's not like, you know, wow, it's really having this huge effect. Something else interesting is that I can compare the R² across the models. So kind of something interesting to look at is when we include those other independent variables like gender and race to the model, the R² jumps up to 21. So now 21% of the variation in our dependent variable is being explained. So there's something to think about as you look at your own models, at future models. It's interesting to think about because obviously if we were talking about something like in the hard sciences, we would not be very happy with like we're explaining 15% of something. But really in political science, it's quite typical to only be explaining kind of like 30% of what you're trying to explain. So it's not uncommon to be seeing these low R². Okay, so I guess kind of just my main goals for today was I'm hoping that you have kind of a general understanding on what the beta coefficient is telling you and what the R² is telling you of a model. And then, of course, just being able to figure out where you can find those in a table like this, and you know how you can see or whether the relationship is statistically significant or not. How do we feel about that? Any? Pretty good. Okay, so yeah, definitely send questions at any point. I'm going to post another lesson on regression. A lot of it's going to be kind of just reviewing the same concepts, and then hopefully you'll feel good next week kind of interpreting some regression tables yourself within an article. So just let me know if as questions arise. All right. Anyone want to chime in before we sign off? All right. Oops. Uh-oh. Oh, someone was waiting. Oh, no. All right. Well, thank you, guys. I will check in with you and just message me with questions. Bye.